As we talked about last semester, there are two different modes for the increment operator. Prefix, in which the incrementer is used before the value is used, and the postfix, in which the increment is done after the value is used. So you can see here y equals plus plus x. That is equivalent to x equals x plus 1, then y equals x. Whereas in the postfix operator, here we have y equals x plus plus, which is equivalent to y equals x, and then x equals x plus 1. So you see the difference. This order right here gets changed depending on the operation. All right, let's run through a couple quick examples just to bend your mind and just refresh your memory. So we've got some code, right? And here's the program trace for it. X is equal to 4, and then we increment it beforehand, so x becomes 5, and then y is set to the result. So here we have y is equal to 5, so our output is 55. Okay, pretty straightforward. We set x equal to 4 again, right? And y is still 5 from our previous operation, but then we do our incrementer. So we're going to evaluate x, which is 4, and then increment it. But before we increment it, we're going to assign it to y. So the result is going to be x is 5 and y is 4. And you can, that lines up with this line of code right there. So our output is 54. So here's a little bit more of a tricky one, right? We have b is equal to 2, a is equal to b, and then it's postfixed operator. So this is 2, but then the incrementer operator takes hold and b becomes 3, right? Now, so these are going to get added together. So a is equal to 5, and then we're going to assign the value of b to b and then increment it, right? Well, remember that the increment operator is the same thing as b equals b plus 1. So even though b at this point is 3, and we're storing 3 in b, we're then later incrementing it. So b is going to become 4 just because of this operator alone, right? It has nothing to do with this assignment. So if we look at the printout, we're going to see that we're going to get the same thing. A is equal to 5 and b is equal to 4. Now, decrement operators work the same way, except for that it's in reverse. So here we have a, b, and c. A is equal to 8. B is equal to minus a, so b is going to be equal to 7, right? And then c is going to be equal to 7 plus 2, which is going to be 9. But then b is going to be decremented, so b is going to be 6. So we're going to get 7, 6, 9. Hopefully that made sense. Operator precedence determines the grouping of operands to operators when an expression is surrounded by two operators. So these two things are equivalent, right? It's going to do this first, and then it's going to multiply them together, and then it's going to add in the y. But the trick here is that when the compiler actually figures out what the values for y is, it's going to do the operations in a certain order, but it's still going to get the values. So what do you think this code is going to print? Well, it's going to print z equals 20 because it's going to come through and it's going to say, okay, y is equal to 3. And then it's going to say, oh, but we're incrementing y here. So this is going to be 4. And then we're going to multiply it by y. So that's going to be 4. So it evaluated them from left to right. But then it's going to do the multiplication and then do the addition. So we're going to get 16 plus 3 is equal to 19. So this stuff can be really confusing, and you shouldn't really be doing stuff like this with the same operator. You just have to be aware of with the increment operator and the order of operations, so you don't get yourself confused and get some kind of, off by 1A or whatever because you're trying to be clever and incrementing your stuff inside of complex operations. It's fairly common to embed an assignment expression inside a loop condition. For example, in this code, we have an embedded operation here inside the loop. The program gets its input from the user, and then it's evaluated from left to right. So this next double gets stored inside the score, and then score is then evaluated with -1, right? So it can be kind of tricky that way. Conditional operator expressions implement if-else logic using a more compact form, like this. We have a conditional statement that can evaluate to true or false. If it's true, we return this value. And if it's false, we return this. So here's an example. If x is greater than y, then return x, else return y. In this case, it would be 5, right? Because x is less than y, so we are going to return the value of y. Conditional expressions are really, really useful for writing nice, concise code. When you first look at them, they're kind of confusing. You're like, what? But it's just a really nice way to write like really quick and short snippets if you need an if-else block. So here's another example where we're actually using it in code. Whoops, we forgot the semicolon here. Int z equals x is greater than y. If it's true, it's going to be x, and if it's false, it's going to be y. So we've got the same logic over here, but now we're just actually putting it into a Java statement, right? So what's going to happen, it's going to evaluate this expression and then say if it's true, x, otherwise y. And in this case, y is going to go into z. Again, we can't use a conditional operator expression by itself. It has to be used with something else that's going to use what it returns. Like it can return something as part of a method, or it can be used in an assignment statement, but it just can't be used by itself because there'd be no point to it. So here's another example. Here we have score equals 58, and we're setting this extra credit variable to true. So this is saying score is we're going to increment score by extra credit. If extra credit is true, then we're going to increment it by 2. If extra credit is false, we're going to increment it by 0. So in this situation, we are going to increment the score by 2. So this is going to get added to score. And then we're going to print out grade equals, and if score is greater than or equal to 60, we're going to print out pass. And if score is not greater than or equal to 60, then we're going to print out fail. So in this case, we are going to print out pass because our score is 60 because we had 58 plus 2, right? And that gets stored into score. And then score is now equal to 60. And so that's going to meet the pass criteria. And so grade is going to be equal to pass. So here's another little mental exercise. Using the conditional operator and not the absolute value method available in the math class, write a one-line code fragment that implements this pseudocode. And I'll wait. And by saying I wait, I mean pause the video. Okay, hopefully you figured out that in order to calculate the absolute value of y, and in case you don't remember what the absolute value of y is, it's if the value of y is negative, just return the positive version of it, right? So if y is -3, then it's going to be 3. If y is -5, then return 5, right? So how do we do that? Well, if y is greater than or equal to 0, or greater than 0, return y. Otherwise, return -y, right? And this could be greater than 0, because if it's 0, -0 is 0, right? So that doesn't matter. But we could say greater than or equal to. If it's greater than or equal to that, then y is going to be equal to the positive value. Otherwise, it's negative, and if we take a negative of a negative, we get a positive. So now, if it's less than 0, the positive value is going to get multiplied by -1 and become a positive value.